as a heads up, we have about 9 minutes to go, where you get credit for as much progress as you make if you don't finish.
Okay. Yeah, well, probably won't be able to finish it, but let me try. My name is. I've been a software engineer with Atlassian for the past almost 3 years. So Atlassian makes enterprise collaboration software like Jira and Confluence. So our team manages the runtime authentication on the identity space.
Yep, nice. So thanks for taking the time to share background with me. Which principle of object-oriented programming most helps manage complexity of a software model and why?
I think polymorphism helps to
what's the principle you said?
Polymorphism, okay, different properties of how it works. I can't remember the single one.
Why is it polymorphism?
Basically, you can define different ways a function could work. I think that's why it is. There's also that's the only one I can remember. Also, ways you can overload a function, right? And define to take different input. I don't remember the exact.
Okay, got it. So thanks for that. Now for the next one. Choose the most appropriate data structure for each of the problem types below.
Hierarchical file system model. We have stack. Orders to the processing order and sequentially should be appealed. One option flag on memory, function, device. Also map. Yeah, something like this, I would say.
Thanks for those.
With rapid fire questions like these, it's a bit hard to know at times if you're correct or not. The interviewer sort of has to keep the schedule, so we can't really stop to say if you're correct or not, but yeah.
So now we can jump to the next one. Explain what a race condition is and give an example of why one might occur in code.
Oh yeah, so for example, banking, right? If the bank originally has $100, one person tries to withdraw $20 at time equals to 1. If there's at the same time another request comes in to withdraw $20. If these transactions are locked, basically the second transaction will also read the bank has $100 and take consecutive change to the
And why would one occur? How would you prevent the race condition?
Have locking mechanism. Probably a mutex lock. Yeah.
All right. So thanks for that. Now we'll jump to the next section, performance issues and troubleshooting. Let me give you the first question. The following SQL query seemed to perform fine in development, but now in production is running increasingly slow and sometimes timing out. What are some potential reasons why the query is slow?
First of all, set start station was entry from the rows, so that could be one of the reasons we getting too much data. So the application I use. And that's this time. We could be getting a really large time, so we could be putting too much data in the prod environment because prod has much more data than that, right? So that's one of the reasons. Yeah.
All right, so thanks for that. Now
there's also a
please grab sounds good. So now for the next one. Identify the type of issue represented by the diagram on the right. Give an example of why it might occur. And once you diagnose the issue, how would you find its source?
So RAM is not really changing, but CPU is changing. So it's not recursion because we're not using more memory. We just malfunction CPU. We're getting more requests. Oh, actually, if we're getting more requests, RAM will also increase. So it could be CPU malfunctioning. That's just doing idle work. Getting hand and with a loop or something.
Yeah. So, and how would you find the source of the issue?
Probably use some kind of JVM tool to find where it's getting stuck at.
You'd use a what tool, you said?
JVM, not really memory, but you can check different CPU usage on different process. Because which process is taking more than 60 hours.
All right, so thanks for that. Now for the next one. Your team is building a RESTful API of the following form that returns a purchase history for a given customer ID from an online retailer. How would you benchmark the performance and the capacity of this API?
Benchmark the performance. So we have metrics. We need to have metrics tracking all the traffic going to this endpoint.
But
basically, track
how exactly would you benchmark it?
We record the latency, basically the time it takes for the request to receive the request and return response.
Yes, but I guess what exactly are you doing as part of the benchmark? Before you get to the metrics or before you get to the recording, what are you doing? What does it mean to benchmark it? What would you do?
You have a definition of what we want to measure as a performance for this endpoint.
Yes, but I'm saying before you get to measuring, what are you measuring? Like, how are you testing it? How are you benchmarking it?
Oh, make sure this API is returned correctly we can get data from this API.
Okay, and data from the API. All right, so thanks for going through. Imagine you're keeping track of the courses that different students are taking in a university, and you'll be given a list of pairs where the first entry is a student ID number, and the second entry is the name of the course that student is taking. So I want you to write a function that takes in this list of student ID number and course name pairs as input, and I want you to return for each pair of students a list of all the courses they share. So if you look below line 25, you'll see for the output of the function you're going to write, find pairs, and you're given enrollments 1 as input, So you see we have 58 and 17 as the first pair, taking software design and linear algebra, because if you look on the data beginning on line 10, if you look at all the courses student 58 is taking, and you compare them with the courses student 17 is taking, you'd find the only courses they share are software design and linear algebra. And you want to do the same thing for the other pairs of students. And if the students don't share any common courses like 17 and 94, then you can just return an empty list. So you can take some time and review the problem some more. When you're ready, you can let me know what approach you want to use to solve the problem. And once you describe your approach, then you can get started coding.
So I want to first store EXECutable appearing a map, P being the student ID, and value being a list of courses the student will take. And in the result we want to generate, we are converting it to pairs of two students. So we need a for loop, a double for loop to generate all the pairs.
Okay.
And for each pair, we get both lists of the two students, right? And check the intersection, find the intersection and add it here as their shared course, and basically just traverse through
that sounds like
all the combination of student pairs. Okay,
yep,
so
like
let me go ahead and
you can get started when you're ready.
Oh, yeah, let me do that. Please hear me. What's that pairs type? Pairs on the other screen. Okay. Yeah, we'll read this. Okay. Yeah. And then, of course, right. So after this, I'm getting recent students, of course. So I'll just take an example here. Okay, this is 95 pairs. So for stream, P set. Oh, students, P set. So that was student 1 for equals to student 2. Continue. Basically, see how students course result stream courses 1 equals to students get student 1. And courses 2 will equal to get student 2. And if I go to the top section, I'll do this in Java. This section is in Java. Okay. We're using fit my course 2 contains that into this. Wait. See. So. Okay, cool. My answer. Basically, if algebraic key, which is my key, if that contains the already handled scenario answer. You can see it. That should take a place before this enters this. Else, answer the output key, what is value, which is okay. That's what it here. Alright, so once I finish this answer. So now let's see. Let's input me here with elements 1. This will give me a hash map, right? Of string and place of strings. Result equals this. So I do a system out document. But my change is key 4, string key result key set. System out document. Well, formation like keep it cool. Okay. Key plus. We have 6 here. Okay, so. It's a string, so. Yeah, I do print the string.
Here's the result, not that.
Oh, okay. Yeah, I was actually waiting on it. I was putting it in hard. Oh, yeah, first I actually got. Those are courses. So key, no longer courses, and then like, I mean, 5 and 50 have coins. 7 and 50 have basically 7.5 0 nothing. 25 and 94 coins, and 7 and 94 empty. Yeah, that's okay. Sure, me. This whole key is just here. And I choose result. 1 and 2, and 1 and 3. So, browse on center, choice answers. So, no, it's a nice test. So, let's try this. Okay. Right. So second case.
So what's the time complexity solution? And if you look on line 98, you see where we define N, S, and C.
Okay. It's number of students. So let me copy this and go to my code so I can better analyze it. Okay. Number of students here in the input. So I'm traversing through all the students and all the courses. So that's ON when I try to build this map in this for loop. So here, after this, I have O of N. and I'm going through all the student pairs, right? That's really what I'm doing, by doing a double for loop traversing through all the pairs. There are duplicates, I'm skipping that, but the worst case scenario, number of students is S, so that would be O S squared because I'm getting all the combination, right? Then all the combination will be worst case scenario S to the square. And basically adding for finding the intersection between the course, I'm using this helper function. If I were to write it myself, I would add this course into a set and
okay. But for what you currently have, what would you say the time complexity is?
Basically, traversing through the other days will give me the shared course. So basically, worst case scenario is traversing through all the course because one student might have taken all the course and another student might have also taken the other course. So traversing through this here takes all of total number of cores is C, right? So the worst case scenario is inside this combination, I'm also doing a OC operation to get the shared course. Then it's S to the square times O to the C. That's my time complexity, which will be bigger than ON. So, yeah.
Okay, and the space complexity?
Space complexity will just be the, I have an answer array and student array. So answer array will be number of students to the number of courses. So the maximum length for, so yeah, actually let me write it about time will be this. And space will just be that array, which will be number of students is S. Courses, I'm putting it into a list. So yeah, the number of keys in this will only be S. Right. Oh, actually student pair, the answer I'm returning will be more than S, right? So the pair could be S to S squared because that's a number of different combinations.
All right, yeah. So thanks for going through that for me. So now we'll jump to the next question. So this time, you're keeping track of the courses that a single student is taking in a university, and you'll be given a list of pairs where the first entry is the prerequisite that must be taken before the second entry. We'll say that each course has at most one prerequisite that must be taken first. No two courses share a prerequisite, and the student is guaranteed to take all of their courses in a single linear order through the program. So I want you to write a function that takes in the list of prerequisite course pairs as input, and I want you to return for each pair of I want you to return the name of the course the student will be taking when they're halfway through their track of courses. If there are an even number of courses, which would mean two middle courses, you want to return the first one. So if you look below line 18, you see this is the order the student has to take their courses based on the input given. So the output on line 28, data structures, because if you look on the order of courses, you see that out of these 7 courses, data structures is a course to be taken when they're halfway through. So again, you can take some time and read through the problem some more, and you can let me know your approach, and then you can start coding.
Yeah, so let me read this through again. There's only one pass through as a function, so this is a prerequisite course. Oh, so this is a prerequisite for this course, right? Same for this to this. So one course could have just one prerequisite. Is that what?
Each course has at most one prerequisite.
So basically finding this pass. Okay. My approach would putting them again into a hash map. From the prerequisite as key to the next course I can take. Oh no, might not be the case. Computer networks, computer agriculture, then data structure. Oh, okay, yeah. So basically just putting this into a map first, this being the key, this being the value. I also have an index to see.
Okay.
I need to find the first course.
Right? How do you find the first course?
Find the first course will require me to go through the value and check if the key is not in the value. the key that's not in the value will be the first course because it has no prerequisite for that course. So in this specific example, software design is not in any of these values, right? So I take software design.
Yeah.
So basically, after I find this, I have it inside of a queue. Basically, I get it out of the queue. No, not a queue. I just traverse through the map. I get the key, get the value, and this value becomes the key again. I get the next value, which computer networks will be computer architecture. Continue doing it until I reach the end. Operating system will be a value that's not a key in the map. That's where I end. So as I'm doing this, I put it into a list, and the middle of the list will be the middle course, which is data structure. That I can return.
And then after you find the first course, how do you find the middle course?
After I find the first course, I guess I know the total number of courses, right? I can just traverse half of the time while I'm going through the map. So I don't need to traverse all that.
Yeah, that's not a very good approach. So you can get started when you're ready.
Yeah. Let me do that. Taking a stream. This will be string to string mapping. Yeah. Course map. Yeah. Why is it? Can you put on array type of course map? Okay. So after this is done for string p course map p set. Not convert any type string to string. Oh, so this value right here. If the value does not contain this key, then we find the first course first. Break out it. Okay. So now I keep going. Int times equal to size. So I mean you halfway point. So if the total number of cores, this is 1, 2, 3, 4, 5, 6. So there should actually be 7 cores. 1, 2, 3, 4, 5, 6, 7. So one more than the number of key value pairs. So I need to do +1 divided by 2, right? So if it's 6, there are actually 7 cores divided by 2. Then I need to 7 divided by 2 take the floor values. I need to do this 3 times. Let me see if that's actually correct. So this, I go one time to here, one time here, one time here, I find data structure. Okay. So I'm greater than 0, right? I do close here. Oh, no, I do not need to define this. Okay. Right. And time. Actually, you can do this. Right. And then I just return first course. Let me try this. I'm not sure if I might mess up the math a little bit, but I think I can figure it out once I have the unit tests ready. Yeah, pairs. Logic and algorithm.
We're going to choose the second and third test cases. Second should be foundations,
right.
And third should be data structures.
Oh, okay. Let me see what we're on here. I do the math. So this is a prerequisite, and this is a next course. So the middle course should be the second course in this case. Is that right? So here my map size is 1. 1 plus 1 is 2. 2 divided by 2 will give me 1. So time is greater than 0. So my first course, I should pick data structures. I will get data structure. You should return the algorithm. Why is it not doing that? So let me fix this case first. Right. So let's see if I pick first course correctly. And also let's see if I calculate my time correctly. So first course is data structure. Oh, I should keep data structure instead of algorithm.
Yeah.
Oh, I keep algorithm.
Right.
Return
the first one.
Yeah. Oh, yes. Right. So that's why. So I should not do +1 probably. I should just divide it by 2. That way, if it's a number, it will always be. So in this case, if current is 1, even though the size is 2, divided by 2 will give me 0 the first time. And let's try. Try data structure from.
Okay. So what's the time complexity solution? And if you look in line 57, you see where we define n.
Oh, okay. N is pair of input. Let me move it here. I'm at 994 right now, so let me analyze the runtime and space. number of pairs in the input becomes number of pairs in my map. So space is actually just ON, right? I'm basically saving those number of pairs in my map. And runtime, after I traverse through this number of pairs, I traverse half of the pair to get the middle course. So essentially it's still ON. It's ON plus ON divided by 2. So that's still ON.
Yep, so that looks good. So thanks for going through that. So now we can jump to the next question. So this time, students may decide to take different tracks or sequences of courses, and there may be more than one track that includes the same course, but each student follows a single linear track from a root node to a leaf node. So I want you to write a function that takes in a list of these source destination pairs as input, and I want you to return the name of all of the courses that the students could be taking when they're halfway through the track of courses. If you look below line 23, you see for the output, we have a list of these 4 courses, because these are all the possible courses students could be taking when they're halfway through. If you look below line 26, you can see all the possible paths the course students could be taking of what all these paths look like. So again, you can take some time and read through the problem some more, then you can let me know your approach, and then decide how you code it.
So these are still source and destination logic. Also, it's still prerequisite for the other course. Algorithm, data structure. Oh, so it's like a map. It's like a graph, I mean. Okay. So my intuition is to build a graph. Because one course can lead to multiple different courses, right? Build a graph as a key value pair. The key is just a course. Value can be a list of other courses you can get to. And you really want to return the name of all the course as a student could be taking their halfway through. So after I build a map, I know the total number of course. I know then I can calculate the halfway point value. Then it's basically doing a DFS to traverse through all the possibilities and get a course that's in the middle value. So, actually no, only 2 courses. I do not need to traverse through all the courses. I need to know which 2 courses have no dependency, or which courses have no dependency. Okay. From those courses, in this particular case, just these 2 courses, I run a DFS for them. So these are 4 different combinations. The DFS will return in the middle course. Yeah, and same for the other one. So yeah, that's my intuition on how to do this. Does that sound like a good approach?
Yeah, that sounds like a good approach. So you can start when you're ready. As a heads up, we have about 9 minutes to go, but you get credit for as much progress as you make if you don't finish.
Okay, yeah, we probably won't be able to finish it, but let me try. So I need to return a list of string, right? Find middle. So building my graph. That's the thing I want to do now. List of string. Electrical way. Okay, cool. So building a graph. I should also have a count of all the courses. Yeah, so I can find the midway point for a course, 2 courses. Right. Yes. Then course map.get course 0. I also need to know which course does not have a dependency, so I should begin with which course. So I probably need something to figure out as well. Let me see how I can do that. So I can have a hash set to put all the courses that require a prerequisite, right? And I traverse through all the key. If the key is not in some course that requires a prerequisite, then I know that's the first course I got to take. So that's how it's spelled. I'm building this map. I also do prerequisite. Course 1. Okay. So I know the course that will require a prerequisite. So then my list course first courses, right? You can find my first courses by going through my course map piece set. If course map not course maps. If need prerequisite contains. If this does not contain this current course, means it does not need any prerequisite. Then I can do first course ahead this course. Okay. So I also said I want to count distinct courses. So distinct courses, the count is really just the number of course that needs prerequisite, right? So new prerequisite, because it's a set, it's distinct. The size of that, and the first courses is also distinct because I only traverse through distinct keys. So these are the total count of course I have. So the midpoint will be middle, will be this value divided by 2. Now I need to do a BFS. Let's see. I start from this. Actually, I do a BFS would be better.
Yep.
So the first time from intro to CS, I get to this 2 course, and I reach my middle point. I break. I just add. Oh no. Oh, that's not how it's calculated. It's a non-gist pass. It's the middle of the non-gist pass, right? So we want to return networking because in this pass, it's in the middle. Oh, okay. That's actually can I use this as a helper function to help me do that? Let's see. Right now I find my first courses. I also have my map. Oh no, but this is only 1-to-1 matching, so I cannot do that. So DFS does not work here because each pass could have different lengths. So I still need a DFS. But as I enter, I reach the end and it returns. I reach the end, I know the maximum length and it returns. I can backtrack to a middle point and then add this to my list of answers to return. Okay. So for courses, I need to perform this DFS. So we have a helper function with this map, which is course map, and pass the first course. So this DFS function should return a middle course. And basically my answer should add this middle course. And I also need to deduplicate because in the example, also data structure could be there. So yeah. So I could deduplicate in the
Yep. So we're about out of time now. But like I said, you get credit for the progress you made. So thanks for taking the time to go through the problem, please.